This is video 8 for paper 3 of the higher mock. So this question is all to do with upper and lower bounds. Now, we've got to look at the context of this question just when we're working out the final answer. So I'll come back to why this question is a little bit different to normal in a moment. First thing you do as soon as you realise it's an upper and lower bounds question is you work out the upper and lower bound of each of the numbers that you are given. You've got to do this before you do any calculations because the calculations are meaningless if you just use the numbers given in the question. So if we start off with the maximum weight of the bridge, which it says, I say the maximum load for the bridge is 1,500 kilograms to the nearest 10. So if you're doing it to the nearest 10, if you half that to give you 5, it means that the upper and lower bound will be 5 above and 5 below. This is a tactic we can use with any type of bounds question. Take whatever you've rounded it to, half it, and it'll be that much above and below for your upper and lower bound. So if we use the same idea for the soldier is 75 kilograms to the nearest kilogram. So here we've rounded to the nearest 1 kilogram. So half of that gives us 0.5 kilograms. So 0.5 above and below would give us 75.5 and 74.5 kilograms. Now, as I mentioned before, this is a little bit different. It wants us to work out the maximum number of soldiers that could cross the bridge safely. So if we are being really safe, we've got to assume that this maximum load of the bridge is a little bit too high. So I'm going to use the smallest load that the bridge can take and divide it by the maximum that a soldier could weigh. So that's my 75.5. If I do this, it comes out as 19.801. Now obviously we can't have that many soldiers, so this would have to be rounded down in order for it to be safe to 19 soldiers. The next question is a probability question. Now you could, if you wanted, draw a tree diagram for this. However, there is a much quicker, easier way than without having to draw all of the branches, because obviously there are 3 options for each of these, so it's going to be quite a complex diagram. So the easiest way we can do it is this. If I wanted to find out the probability that they are both the same, there are 3 possible ways this could happen. I could get red, then red, blue, then blue, or yellow, then yellow. Notice I've put a times in between each one because that's what we do with probabilities when we're working out the probability of 2 things happening one after the other. So the probability of it be picking out a red counter would be 6 out of 15. If I've already picked one of the counters out, the probability of the next one being red would be 5, because I've removed one of the red counters, over 14, because one of the counters has been removed. If I times these 2 together, it gives us 30 over 210. I'm not going to simplify that because I'm going to need to add that to the answers here, and it's probably going to be easier to leave it in this form. For blue, it's going to be 5 out of 15 that I pick out my first counter and it's blue, multiplied by obviously 4 out of 14, so there's 1 less blue and 1 less counter altogether. So this gives us 20 over 210. And then for yellow, because there were 4 yellow counters out of 15 to start off with, that's the probability of the first one, and the probability of the second would be 3 out of 14. So that gives us 12 over 210. Just remember when you're timesing, just times the top times the bottom. I then need to add these 3 together. In order to do that, I simply add the numerators. Because I've left the denominators the same for all 3 fractions, so I can just add the numerators. So here we've got 30, 50, 62 over 210, which when simplified gives us 31 over 105.